Okay, in this short video, we're going to have a look at an exam question from the fuels topic of Year 11 chemistry. We'll look at some correct answers and some incorrect answers and discuss some of the misconceptions that students had. So the question starts talking about fuels being obtained from crude oil. Quite a straightforward question to start with. Okay, multiple choice question. Okay, which statement about crude oil is correct? Okay, well, if we look at each one, crude oil is a compound of different hydrocarbons is incorrect. It's a mixture. For B, crude oil is a mixture of hydrocarbons. That's correct. For C, crude oil contains different hydrocarbons, all with the same molecular formula. That's incorrect. They don't all have the same molecular formula. And for D, crude oil is an unlimited supply of hydrocarbons. We know that that's incorrect because actually it is a finite resource. That means it will eventually run out. Then on to B, it talks about fractional distillation, separating crude oil into several fractions. Two of these fractions are kerosene and diesel oil. It asks us to give a use for each of these fractions. So if we just have a look at the answers, okay, kerosene was fuel for aircraft, jets, lamps, cooking heaters, firelighters, or rocket fuel. Diesel is for cars, trains, trucks, lorries, vehicles, etc. Okay. If we look at the examiner's report, okay, candidates performed well, the vast majority of people being able to state a use for kerosene and diesel to gain both marks. We've got a good example there. Kerosene is used for fuel in planes, diesel for fuel in large trucks. An incorrect answer, okay, we've got here fuel for large transport systems, brackets, planes, trains, and then fuels for power stations. Okay, so these are not correct. Okay, the first problem here is yes, kerosene is a fuel for planes, but it's not for trains. So by putting that trains answer, that's negated the whole mark for that question. Okay, and it's power stations isn't a use for diesel, so it wouldn't score. So when it says here, when asked to give a or one use, don't give a list. Okay, another example here. Petrol for aircraft was wrong. It is fuel for aircraft. We can't use the term petrol because petrol is a different fuel entirely. Okay, and then diesel oil, we've got fuel for cars and trains. So that one would be okay. Then on to fractional distillation. It says in the question, figure 1 shows where the fractions kerosene and diesel oil are produced in the fractionating column. Kerosene is obtained higher up the column than diesel oil, and kerosene and diesel oil fractions have slightly different properties. It says choose a property and state how this property for kerosene compares with the property for diesel oil. So what could we choose? Okay, any of these, okay, boiling point, melting point, ignition, viscosity, flammability, volatility, and density, okay? The most common ones really to pick here, I think, were boiling point. Okay, if we're saying for this question, it asks us to give the property, so we could say the boiling point, and then kerosene would have a lower boiling point because it's higher up in the column, okay? Its melting point would be lower. It would be easier to ignite. It would be have a lower viscosity, a higher flammability, a higher volatility, and a lower density. Again, if we look at the examiner's report, it says candidates answered this question well, with the majority being able to correctly compare a property of kerosene with that of diesel oil. So this one here, we've got viscosity. Diesel's more viscous than kerosene. That was the most common answer seen. We've got the length of the carbon chain. Kerosene's got a shorter chain length. Okay, it says where candidates didn't score the mark, it was often as they had the comparison the wrong way around, or that they gave an answer that referred to the length of the carbon chain, which was ignored. Okay, so we weren't able to talk about the actual chain length for this question. For part C, we've got figure 2 shows the formula of a molecule of butane and a molecule of pentane. Okay, and they're neighbouring members of the same homologous series. It asks us in this question to explain, using these formulae, why butane and pentane and neighbouring members of the same homologous series. So it says most candidates could score at least 1 mark on this question on homologous series for recognising that butane and pentane are in the alkane homologous series, and then stated this or the general formula for them. So we've got the mark scheme here. What are we looking for? We're looking for something like they differ by 1 CH2 group, or they differ by 1 carbon atom, or pentane has 1 more carbon. And the second part of this is that they're both alkanes, or they both have the same general formula, or we give the general formula. So this answer here, they have similar chemical properties, they have the same general formula, and they're both hydrocarbons, and they increase by CH2. So we've got the marks for the general formula and for the CH2. In this question, we've got butane has 4 carbons, pentane has 5 carbons, therefore they are neighbouring members. They are both alkanes and therefore a part of the alkane homologous series. And it says in some cases, candidates just restated the number of carbons in each of the molecules rather than describing the difference. So this wasn't deemed sufficient to gain the first marking point, but they still got a mark for saying that they were both alkanes. So you can't really just say the number of carbon atoms. You need to say that they differ by a carbon, or they differ by a CH2 group. Okay, and then the final part of this question, butane has the formula C4H10. It asks us to calculate the mass of carbon in 100 grams of butane and give your answer to 3 significant figures. Okay, so the relative atomic masses are given. Hydrogen is 1, carbon is 12, and the relative formula mass of butane is 58. Okay, so what we've got to do is calculate the mass of carbon in 100 grams of butane. So if we look at this, for every molecule of butane, there are 4 carbons. Okay, carbon has a relative atomic mass of 12. So we're going to say for this one that 48 out of the 58 are the mass of carbon. So if we do 48 divided by 58 and multiply it by 100, that would give us the answer. Okay. So we're going to say 4 times 12 is 48 for 1 mark. Then we're going to do 48 divided by 58 times by the 100 to give us 82.8 grams. Okay, it's a bit like calculating a percentage. We do 48 out of the total 58 times by 100, it gives us 82.8. Okay. So in terms of actual answers, there's a correct answer here. We've got the 12 times 4 is 48. Okay, 48 plus 10 is 58. 100 divided by 58 is 1.742. Multiply that by 48, it gives us 82.8. Here we've got 100 divided by 58 is 1.7. 12 times 1.7 is 20.7. Okay, so this one, they haven't done it quite correctly. They've multiplied it by 12 for 1 carbon rather than the 48